NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
This is the lunar module. A similar craft will one day allow two astronauts to set gently down on the surface of the moon. Recently, a critical test flight was made to check out the complex space vehicle and its engines.
The purpose of the Apollo 5 mission was to initiate the series of flight tests that will ultimately qualify the lunar module for its part in the lunar landing mission. The important features of the mission were operation of the descent propulsion system, and specifically it was started, stopped, throttled twice, and during the last burn of the descent propulsion system, the ascent propulsion engine was fired to stage the upper stage of the lunar module away from the descent stage, simulating an abort commanded by an astronaut approaching the lunar surface. Then the ascent engine was burned twice, the first time for about 1 minute, and the second time for a total of 6.5 minutes. The objectives of the mission were achieved, and it was very successful and fulfilled its part in the series of missions that constitute the steps in getting to the moon.
The strongest metal known at temperatures above 3,500 degrees. That's tungsten R8C. This new alloy was recently developed by NASA's Lewis Research Center in Cleveland. Tungsten by itself is brittle, but by alloying it with rhenium and hafnium carbide, it becomes stronger and easier to work with. It can be fabricated into many shapes. The newly developed alloy may someday be used in nuclear propulsion systems, engines of giant supersonic transports, and for craft returning from space. Materials research, broadening today's technology for tomorrow's uses, both in space and on Earth. Medical monitoring of astronauts is a necessity, returning a picture of the space traveler's well-being and making a permanent record available for future studies of effects of the space environment. A complicated array of equipment was used during the Gemini flights and consisted of electrodes attached to the body. These return vital pulse, respiration, and EKG readouts. For long-duration manned space flights of the future, a simpler, less restricted means is needed. Studies are now underway at NASA's Electronics Research Center in Boston, with a specially instrumented chair capable of monitoring the heart and lungs, done without the usual cumbersome attachments. Here's a demonstration.
This young lady has now contacted her palms to the electrodes. We're presently measuring the electrical activity of the heart here, the electrocardiograph across the palms. The change in palm resistance is the measure of the respiration and also a pulse rate. Behind me we have a computer system that will not too far different from that. It will be used on the spacecraft itself to allow for data processing and reduction and information format both to the astronaut and return to ground.
Medical monitoring, a necessity for man in space.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.